I am making this video from home. My kids are downstairs singing Moana karaoke, so if you hear a lot of background noise, they are either fighting or just singing really loud. But, you know, that's what happens when it is really, really cold outside. You guys know how cold it is today. So we're starting trig identities, and some kids have told me they heard some rumors that this is the hardest chapter, and I know I've talked to you guys about it. It's just, it's really difficult to, do this. Like for me to tell you how to do it, like you have to kind of do it on your own. It's kind of like doing a puzzle that you just have to keep trying different pieces until you find the way. So we're just going to start with some intro stuff first and then some examples. So my first question is, where is each trig function positive? So I'd actually love for you to, pause and see if you can tell me without me telling you. But I'll go through it. So in the first quadrant, remember, so they go like this, 1, 2, 3, 4. All of them are positive here, okay, because X and Y are all positive. In this one, though, we go backwards, so the X value is, our cosine is negative, and then sine is positive, right, because we would go backwards and up, and that would be your negative X, positive Y. So sine is the positive one in this quadrant. And that's because cosine would be negative, but then so would tangent because you're dividing negative. In this one, you would have a negative X and a negative Y. And so neither sine nor cosine, but if you divide negative by negative, you get positive. So that's, I'm putting a T for tangent there. So tangent is positive. And then in quadrant 4, you would do positive X, negative Y. So that's cosine. Okay, and so a little mnemonic device I use for this: all students take calc. Okay, so there's your little mnemonic device for this. And then the next little thing I have for you here is sine squared plus cosine squared. What is it if x is 30 degrees? So if I draw my 30 degree, remember I don't memorize this. So 30 degrees, this one. And then I asked what would be sine squared. So that's 1/2. And then square it. And then cosine squared. Well, cosine would be square root of 3/2 squared. So I'm still looking for what this equals. 1/2 times 1/2 is 1/4. And then the square root of 3/2 times the square root of 3/2 would be 3/4. When I add them together, I get 4/4, which is 1. And this ends up being really important because for any x, whether it's in degrees or radians or whatever degree it is, sine squared x plus cosine squared x equals 1. And then that's something I'm going to give you, actually. So I will link to the handout on Schoology, but then also I'll hand you one, and it's something kind of like your unit circle that you'll keep handy for a really long time. So to kind of explain where I'm going with this, I kind of did old way, new way. Just because we've done this a few times differently. And so I'm saying, like, if sine of some angle x is 3/7, I want you to find cosine x. But then I'm saying that x is between pi/2 and pi. So that would be, this is pi/2, this is pi. So I'm going to be in quadrant 2 here. And so I know that the only thing that's positive in this one is sine. Remember, we're going to all students take calc. So sine is positive, and I know that here. So if I drew my triangle that had angle x, I would say that my opposite, right, sine SOHCAHTOA, opposite was 3, and hypotenuse was 7. And then I'm going to guess that you would find the y value here by saying a squared plus b squared, whatever you want to call it. Maybe b if you like x and y gets a little crazy. So then we would say, like, b squared plus 3 squared equals 7 squared. And this is 9 and 49. And when you subtract, you'll get this. And we'll get the square root of 40, which when you reduce it, I believe is 2 square root 10. So you would then take this and put it here, and you would remember that this needs to be negative because you're moving backwards. So this is negative 2 square roots of 10. And then if I asked you for the cosine of x, so cosine is adjacent over hypotenuse. So this is the way we kind of used to do it. Okay, and it's not wrong. It's just a different way to do it. The new way we're going to use our trig identities. So if you have that printed out, or I'm going to give it to you, the new way is going to use the trig identity, or the fact that sine squared of x plus cosine squared of x equals 1. And so I don't know all of this, but I know what sine of x is. And sine squared just means I'm going to take sine x times sine x. So sine of x is 3/7. So I'm going to take 3/7 and multiply it by 3/7, which is squaring it. I'm actually solving for cosine x, but we'll get there. So this should be 9 over 49 plus cosine squared x equals 1. And now I need to subtract 9/49. So subtracting 9/49 over here too. But to do that, I probably need to change this into a fraction. So I'm going to change it into 49 over 49 because that's 1. And things should start looking familiar here because I get cosine squared x is 40 over 49. And to get rid of this squared, I need to take the square root of both sides. So then cosine of x is the square root of 40 over the square root of 49, which is 7. And then the last thing to do would be to come back to my thing here, like, oh, is cosine positive or negative in quadrant 2? And I know I'm in quadrant 2 because of this right here. It's negative, so I need to put that negative symbol here. So I got the same answer. Okay, these are equal to each other, but I did it 2 different ways. And so going forth, we're going to be using these identities. And you can kind of fall back on this on the old way to start with, but as we keep going, knowing these trig identities is going to be really important.